Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you half adder and full adder. This video is not only about understanding of half adder and full adder. Here we are also deal with to understand how exactly we will be utilizing half adder and full adder inside computer circuit. Like if you observe computer, in that we perform various categories of tasks. Obviously you do perform addition, subtraction, right? As well as we perform multiplication, division. Many logical operations even we perform inside a computer. So all those things that we can do by using half adder and full adder. Like with half adder and full adder, we perform 1-bit addition, right? But if you want to perform multiple bits of addition, if you want to perform multiple bits of subtraction, if you want to perform multiplication and division, that you can do it with the usage of half adder and full adder. So in this video, with some practical analogy, I'll explain you how exactly we will be using half adder and full adder in computer circuits. So let us try to understand first how exactly basic structure will be there with half adder and full adder. So as if you see the basic structure of half adder, in that we will be having two lines of inputs. Let us say those inputs are A and B, and outputs are sum and carry. So in half adder, we'll be having two lines of input, right? And here we perform 1-bit addition only, but lines of inputs are 2 and output will be sum and carry. In full adder, we also perform 1-bit addition only, but input lines are 3. Let me show you how. So with full adder, we'll be having 3 lines of inputs. Let us say those lines are A, B and C in, and outputs are sum and carry. So dear students, with full adder, we perform 1-bit addition only, right? But number of lines of inputs are 3. Now my dear students, here once you understand that basic structure, right? How many inputs are there, how many outputs are there, you will be able to understand how we can use. For example, here with single half adder, we can perform 1-bit addition. With full adder also, with single full adder, we can perform 1-bit addition. But what if you want to perform multiple bits of addition? So that even we can do it by having half adder and full adder. Let me show you how. Let us say we are having A and B that is having multiple bits. So here I'm going to consider 4 bits with A and 4 bits with B. So let us say A is having 4 bits and those are A0, A1, A2 and A3, right? That is how 4 bits are there with A, and with B, B0, B1, B2 and B3. That is how 4 bits are there. Now I'm going to perform addition of this multiple bits, right? So first of all, you'll have to add A0 and B0. So this addition, that is similar to half adder. You see, in half adder, how many lines of inputs are there? 2, A and B. So here we are having 2 inputs, A0 and B0. Addition will be sum and carry. So here sum will be S0, carry will be C01 over here. So this addition, that is similar to half adder addition. So this is one half adder that we are using for 4 bits addition. Now let me explain you how exactly further addition will be there. So if you observe now, we need to add A1, B1 and C01. Now, as if you want to add these 3 lines, you see that is addition which is similar to full adder addition, in which input lines are 3, A, B and C in, right? Output will be sum and carry. So this addition, that is similar to full adder addition, in which sum is S1 and carry, let us say over here, that is C02. So this addition, that is similar to full adder addition. Now for further addition, you see here sum will be S2, carry will be C03. Here further addition will be having sum S3 and final carry, that is C out. So here, my dear students, if you observe this addition, that is similar to full adder addition. This addition, that is similar to full adder addition, right? So here, if you observe one thing carefully, one half adder that we are using for 4 bits addition and 3 full adder that we are using, right? So here, my dear students, what we are doing, we are adding 4 bits. So to add 4 bits, you need 1 half adder and 3 full adder, right? So if you want multiple bits of addition, let us say you want to add 8 bits, right? Then you need to have 1 half adder and 7 full adder. That is how multiple bits of addition that we can perform. Once you know how we can have multiple bits of addition, using Booth's algorithm, we can perform multiplication as well, right? So in multiplication, we'll be using half adder and full adder only, right? But that small section which is performing 1 bit addition with the usage of half adder and full adder, that will be always there for all those operations, right? Now, my dear students, I'm going to explain you how exactly we can have half adder, right? So I have already explained you how exactly we have half adder, right? In which 2 lines of inputs are there and sum and carry, that will be my output. So first of all, I'll explain you how table is there, and based on that, we'll be making physical circuit of half adder, right? So here when you add AB, which is 0, 0, so sum will be 0, right? And carry will be 0. When you add 0, 1, so addition will be 1. Here no carry is there, right? So carry will be 0. When you add 1 and 0, sum will be 1, carry will be 0. When you add 1, 1, so that will be 2. My dear students, what is the meaning of 2? 2 means 1, 0 in digital. So 0 is sum and 1 is carry, right? So 1, 1 addition, that is 2. So sum is 0 and carry is 1. 2 means 1, 0. So carry is 1, sum is 0. Now here, I don't think I should be using Carnot map to solve this. Directly we can say this sum, that is what? XOR gate. XOR gate truth table is what? 0, 1, 1, 0, right? So here sum, that I can directly say sum is XOR and XOR of A and B, right? So here sum, that is XOR operation of A and B, and as if you see carry, then that carry, that is you see 0001, so that is similar to AND gate operation. So carry is ending of A and B. Here inputs are A and B, right? Now I'll explain you how we can form circuit. So to understand how to form circuit, let us consider inputs over here first. So I'm going to place inputs A and B. Let us extend the line. Now first I'll be explaining you how we can have sum. So that is A XOR B. So here let me connect one XOR gate, and output of this XOR, that is sum, right? So sum, that is my output over here. And second output is carry, that is logic AND operation of A and B. So let us take A and B from here and let us connect AND gate over here. So output of AND gate, that is carry over here, right? So you can say this is the circuit which performs half adder, right? This is the circuit which perform half adder. So now I think you are having fair enough idea about how we can form circuit of half adder. Now I'll explain you how we can have full adder, right? So I have already explained you how exactly basic block will be there with full adder. Inputs are A, B and C in. Outputs are sum and carry, right? So let me explain you first table over here. So in sequence, I have written A, B and C in, right? Starts from 0, 0, 0 up to 1, 1, 1. Now outputs are sum and carry. So when you add 0, 0, 0, sum will be 0 and carry will be 0. When you add 0, 0, 1, sum will be 1, carry will be 0. When you add 0, 1, 0, sum will be 1, carry will be 0. When you add 0, 1, 1, so at that time, addition will be 2 in digital. 2 means what? 2 means 1, 0. So 0 is sum and carry is 1, right? So here, sum is 0, carry is 1. When you add 1, 0, 0, sum is 1, carry is 0. When you add 1, 0, 1, sum will be 0, carry will be 1. When you add 1, 1, 0, means 2 ones are there. 2 ones means what? 2 ones means 2 in digital, it will be 1, 0. So 1 will be carry and 0 will be sum, right? So that is how we will be having this. Now 1, 1, 1 means 3. So in digital 3 means 1, 1, right? In digital, 3 means 1, 1. So sum is 1, carry is 1. So here, sum is 1, carry is 1. That is how we can have table of full adder. Once you have table of full adder, what we can do is, we can perform that Boolean expression with the usage of Carnot map. So here you see, I'm having Carnot map, right? Where first I'll be solving sum. So you see A, B, C in, those are my inputs. So A, that is 0, 1 over here, B, C in, so that I have written 0, 0, 0, 1, 1, 1, 1, 0. Remember, in K map, it will be there as per that gray code, right? So sequence will be like this only, 0, 0, you see, then 0, 1, then 1, 1, and 1, 0. That is how sequence will be there. Always you need to remember this. And regarding Carnot map, I have made many videos based on various complexities of problems, which is there in digital electronics playlist. You can go through there, right? Here, now I'll explain you how to solve this sum. So see, in sequence, if you observe 0, 0, 0, so in box also I have mentioned 0, then 0, 0, 1 means it is 1, 0, 1, 0, so 2 is over here. So 0, 1, 2, and then 0, 1, 1 means 3. Then 1, 0, 0, that is 4, 1, 0, 1, that is 5, 1, 1, 0, that is 6, and 1, 1, 1, that is 7. That is how boxes are there, right? Now, my dear students, we need to place this sum in sequence over here. So this 0, that is there at 0, 0, 0. This one, that is there at 0, 0, 1. Then this one, that is there at 0, 1, 0. This 0, that is there at 0, 1, 1. This one, that is there at 1, 0, 0. This 0, that is there at 1, 0, 1, 1, 0, 1, that is available here. Then 1, 1, 0, that is having 0 here. And with 1, 1, 1, that is having 1 over here, right? That is how numbers that we need to place inside Carnot map. Now here, if you observe this K map, then solution is very simple. See, these alternate ones and zeros are there. So whenever inside K map, alternate ones and zeros that you find, at that time, my dear students, remember this, that will be XOR or XNOR gate. Alternate ones and zeros, that indicates what? XOR operation or XNOR operation. Now out of these two, whether to have XOR or XNOR, how to identify that? For that, you need to see first A, that is having 1 at 1 or not. Like you see this sum that is having A over here, where here we are having 1, right? So 1 is having 1 over here. So what it means, here we are having XOR operation of those inputs, right? So as if you want to solve this sum, then solution of this sum, that is A XOR B and XOR C in. That is how we'll be having sum. Now as if you want to find carry, then from table you'll have to place that inside K map. So this is carry, right? So you see 0, 0, 0. So in sequence I'm writing over here. You see how to write that fast. 0, 0, 0, then 1, 0, 1. So this 1, then 0, then 1. Then after this 1 and this 1 is there. So this one that is available here and last one that is available here. See, this is how I can place it quickly, right? So you'll have to do some practice. Obviously, you'll be able to make it fast, right? Now we need to solve this K map. So how to solve this K map? So for that, I need to make a groups. And here, what is my agenda? My agenda is to cover all the ones. And remember, I need to make group as large as possible, right? So you see, if I want to cover this one, then with the combination of this one, I can have one group, right? And as if I want to cover this one, then with this combination, I can have second group. And as if I want to cover this one, then by this group, I can have covering of this one, right? So that is how we can have groups. Let me show you how we can write that Boolean function. So for that, my dear students, you'll have to see how exactly groups are there. So again, this group that you will have to see, like when you talk about this first group, right? So in this first group, you see this A is changing 0, 1, right? With this group, A is changing, but with this group, if you observe, this B and C in, that is 1 1. What it means? This group, that is B C in, as both are 1, right? B C in. Now various groups that we need to add. So plus, now second group is this, right? Second group is this. In that you see A is 1, that is constant. So I'm writing A. Now with this group, you see B C in, that is 0 1 and 1 1. So if you observe, B is changing 0 and 1, but C in, that is 1, means C in that you need to write. Plus this third group, that is having A, that is constant. I'm writing A. And with this third group, B C in, that is 1 1 1 0, right? So if you observe, C in, that is changing, but B, that is 1, means B is constant. So that is how we can find Boolean function. Now, my dear students, I'm going to explain you how we can form circuit, right? So here sum, that is A XOR B XOR C in. So here first of all, what I need to do? I need to take inputs. Let us say input is A, B and C in over here. So this sum, that is XOR operation, right, of all three inputs. So I'm taking XOR gate over here, and my output, that is sum over here, right? Now I need to explain you how we can have carry output. So carry output, that is addition of BC in, AC in and AB. So addition that we can perform for these three elements, right? So here first of all, for addition I need to have one OR gate, and output of OR gate, that will be carry. But input of this OR gate, that is coming from these three elements, and that is ending operation of BC in as well as AC in as well as AB, right? So first I need to have this BC in. So BC in means ending of B and C in, right? So BC in, that I need to give to this OR gate. Now to have BC in, this C in, that I need to give over here, and this B, that I need to give over here, right? Now second input of this OR gate, that is AC in. So AC in which I need to give second AND gate inputs. So C in and that A, so I need to take A from here. So here this is AC in, right? Now third OR gate input, that is AB. So this is B and this is A. So AND gate that I need to have over here, where output is AB. So this is my A and this is my B, right? So this is my carry, which is algebraic sum of BC in plus AC in plus AB, right? So that is how we can form a circuit of full adder. So here, my dear students, you will have to do some basic practice. Definitely you will make all the circuits, right? But first you'll have to understand things with basic fundamentals. I hope it is clear to you still. If anything that you would like to share it with me, please note it down in comment box. I am ready to reply all the queries, right? Only thing is it will take bit time, but I am always reading your comments. It gives me motivation. Thank you so much for watching this video.